conic section, which is the ellipse or ellipses. And there are only two graphs of the ellipses class. It could be that the ellipse opens upward or not necessarily opens upward. The principal axis is vertical, so this is that ellipse, or the principal axis is horizontal, and this is that ellipse. In terms where I use the words, not principal axis being horizontal, I call this standing ellipse. So para siyang nakatindig, di ba? I call this lying ellipse. Not the lying na makak, but it's, say spelling o kanagahigda. Di ba like this? Or I don't know. Kanagahigda nga ellipse pa, lying ellipse. Look me if I'm wrong with the spelling. Change Y to I and not NG. Okay, so or let's not use that one. It could be that the principal axis here is horizontal, and then here the principal axis is vertical. With that comes the two graphs of your ellipses, horizontal ellipse and vertical ellipse. Okay, so with that, let's first define ellipse class. If we define circle as the set of all points equidistant to the fixed point called the center, and the definition of parabola is that a set of all points wherein the distances of that set point to the constant line or fixed line and to the fixed point is equal. Ellipse is defined as the set of all points such that the sum of those distances from the two fixed points is a constant. The two fixed points are what we call as foci. Foci. So one foci is focus, or the singular of foci is focus. And the constant sum class is equal to 2a. Put this in mind. The constant sum is 2a. Later, we're going to see the illustration of this definition class. So we have here, let's create the ellipse in our own little way and then affix the following concepts in our definition. So from the definition, we'll draw the ellipses having a point somewhere here. So we have a point to where the location of the pencil. And then the two fixed points, what we call foci, are located inside the ellipse. So we have there F1 and F2. Or if not, we can consider them as F sub 1 or F sub 2. Or the most popular notation that we used before is F and F prime, which means the other value of the foci or focus rather. So these distances, the distance of that set point created with the pencil to the first point focus and to the second focus is equal to 2a. And that A will be showcased later. So this is the diagram of horizontal ellipse class. This is the diagram of horizontal ellipse. Notice the values there. With the center at H and K, we'll not anymore use the vertex because the vertex is another name here. The center will contain the coordinates H and K. Then there are two axes. The longest is the major axis, and then the shortest or the shorter one is the minor axis. The major axis is there. That's the major axis. The distance of A to D. Whereas the minor axis is 1. The distance of B to E. Okay? Going back, this is the major axis, the distance between A to D. And this is the minor axis, the distance between B to E. Okay? In some references, we call the major axis as the transverse axis and then the minor axis is conjugate axis. But these terminologies will be discussed further when we have the ellipses, hyperbola, because the transverse and the conjugate axis is mostly common in hyperbola. But for the time being, we'll use the terms major axis and the minor axis. By the way, class, this line here, let me draw a line. If I'm going to draw a line from here until there, that's the principal axis. Get it? The principal axis passes through your ellipse. But the distance alone of your B to E is the minor axis, and the distance of D to A is the major axis. Okay? Notice that in the graph class, you have as well the letters. Okay? From the center at H and K, the distance of point A to the center is noted by a small letter A. The distance of the center to your focus is letter C. In other words, these are what we call as the semi-major axis and the semi-minor axis. Okay? So, kining A class, kini siyang A dire, the A itself is known as the semi-major length, or the semi-major axis length. Because the major axis is 2A. The major axis is twice of A, and then the minor axis is twice of B. B is located here. You notice, nadiri si B. Nadiri si B. So if this is a semi-major axis, this is the semi-minor axis. Whereas P stands for the distance of your focus to the center. In your parabola, we note it as P, right? But here, we'll use the variable C so that we can get the relationship between the variables A and B to C, or A, B, and C. Okay? Okay, so here we go, class. The distance from the center to the major along the semi-major axis is A. I just had that illustrated a while ago. And the distance of the center to the semi-minor is B, noted by this one. This is the semi-major minor. This is the semi-major. Because there are times that I'm going to use the terminology semi-major and semi-minor. Also in the exam, either in the Edmodo or not, I'll also use the terminology. And then the distance from the center to the foci is C. There's no terminology given there. It's just C. Probably we call probably the terminology there could be used. The terminology that we can use there is focal length, because we are trying to figure out the distance of focus to the center. So it's focal length. Okay. And then for ellipses, we have the relationship. This is the relationship for ellipses class. A squared is minus B squared equals C squared. Notice that between the three values class, A is longer, or the longest of the three values. The A, the B, and the C, A is the longest of the three values. So we can apply the Pythagorean theorem's formula here, class. We can use the formula. Instead of having that illustration, we can use A squared equals B squared plus C squared. No? Please do not be confused of the B2. That's B squared. So therefore, if you transpose B squared on the other side of the equation, you'll go with A squared equals B squared plus C squared. In other words, this probably will be in connection with the Pythagorean theorem. No? Since in the figure class here, in the figure above, this probably is the right angle, noted by the major axis and the minor axis. And since this is B, and this is A, so this distance here is your A. What I mean to say is, if this is your B, which is the semi-minor, and this is C, which is the focal length, this will be the end value of your A, which is going to follow the Pythagorean theorem. A squared, or the length of the hypotenuse, is equal to the square of the length of its legs. And that A itself is this A. This A. Okay. And then there are some distortions of your Ellipse class. The formula for that distortion of the circularity there is noted by letter E, eagle, with the term eccentricity. And the formula for eccentricity is C over A. The length of the focus, or the focal length, divided by the semi-major axis. As E approaches 1, the distortion gets flatter. And exactly if A, or rather if E equals 1, the graph looks like a line. But as E approaches 0, this is going to become more circular. If E is equal to 0, the graph turns to be a circle. Your ellipse will become a circle. Okay? What do I mean by this one? If the focus gets closer to the origin, as the value gets closer to 0, E becomes 0. That becomes a circle. In other words, in a circle, have you seen a focus? Wala, di ba? So that focus is eventually the center of that said circle. Whereas if this A gets closer and closer to your focus, the value gets to be 1 since C divided by A, or 1 divided by 1, or A divided by A equals 1, the graph becomes a line. This is just a simple distortion of your graphs class. Question before we proceed? Clarifications? By the way, class, with respect to terminologies, allow me to provide terminologies of the following. Starting off with these points, class. These points. Okay? Instead of using the A and the D, we will not use that one. Instead, we will use here V, and here we will use the coordinates V prime. Get it? So this is actually the vertex, rather, it's not vertex, but vertices. Now, since there are two vertexes, since there are two vertices in your ellipse, so we call this vertex 1, vertex 2, or vertex prime. These are the two vertices. About this one, the letter E, and where's the other letter? Letter B. We will not use B and E. Instead, we will use here B and B prime. Again, the coordinates is what I am trying to emphasize here. This is B, B prime. B and B prime are known as intercepts. Intercepts do not put a letter X or Y. It's just termed as intercepts. So if the question is stated in this way, find the coordinates of the intercepts of your ellipse. That means the endpoints of your minor axis. Okay, intercepts are endpoints of the minor axis, and then vertices are endpoints of your major axis. Get it? Whereas the notations for the foci may not be f sub 1 and f sub 2. Allow me to give you another notation there that would be f and f prime. Okay, so for us to have a uniform solution, no problem with the center, it stays C. It stays at C. Okay, so to understand fully the ellipse class, we need to have the bases, and these bases are the following: the terminologies, the lengths, and how we are going to construct the ellipse basing from the lengths of your A, B, and C. Done? So if there are questions, clarifications, feel free to ask. Some of them are not in your notes, so kindly take down notes then. So the standard form of the equation of the ellipse is this one. Y squared, wait, x minus h quantity squared all over a squared plus y minus k quantity squared all over b squared equals 1. Wherein, if your equation is like this, the center is not in the origin. Because if it is the center in the origin, the formula will eliminate the h and the k. It's just x squared over a squared plus y squared over b squared equals 1. Notice, class, that a here is the denominator of x. Okay? A here is the denominator of x. Meaning to say, the longest length A will be plotted in the x-axis. As we are going to look at the previous text here, A is plotted in the x-axis being the longest indeed three values A, B, and C. Thus, your graph is a horizontal graph, or the ellipse is a horizontal ellipse. So this is a horizontal ellipse. The ellipse is horizontally oriented. However, if the A is the denominator of your variable y, so the A will be graphed in your y-axis. The vertices will be located in the y-axis. Thus, your ellipse is vertical. So if we're going to draw the ellipse having the equation here, if this is our equation class, the ellipse is like that, horizontal ellipse. If this is your equation, the ellipse will be like that, vertical ellipse. See the difference? Again, if the A, put it this way, the A is the biggest of the three values A, B, and C. If A is the denominator of your X, then the graph is horizontal. If A, being the biggest of the three values A, B, and C, is a denominator of your variable Y, then the graph is a vertical ellipse. So these are basically the formulas. I think this is in your module class now. So refer to the module ha. Nana siya diha. Center in the origin, center at H and K. And then potential standard equation. Okay, let's have this example for a while. The ellipse to the equation x minus 2 quantity squared all over 25 plus y plus 2 quantity squared all over 16 equals 1. The question is, find the center, the coordinates of the center, the vertices, the coordinates of the foci, perhaps it's not included here, the intercepts, and find the value of your eccentricity. Let's look at the, let's look back at the drawing beforehand in our previous slide about the ellipse. So this is the ellipse class, right? So A is in the X, and A is the longest. And if you compare the values of your 25 and 16, 25 is bigger than 16. So therefore, this is the value of your A squared, 25. And it is in the denominator of X. So therefore, our graph is a horizontal graph. So the orientation tells us that our graph is horizontal because of that one. Okay? It's pointing to the X, huh? The 25. So let's continue. How about this one? The center in this problem is at, the formula is x minus h, y minus k. So therefore, the center here goes with positive 3 and negative 2. Get it? So you graph that in the Cartesian plane, probably that is in the fourth quadrant, positive 3 for x, negative 2 for y. That is directly pulled out from the equation which is given. Now we're going to find the value of A and B. Notice that in the denominators, we have 25 and 16, and I did mention a while ago that the bigger value goes with A and the smaller value goes with B. Therefore, that 25 class is A squared. So A therefore is 5. How did we get 5? Get the square root of both sides of the equation. Square root of A squared is A. Square root of 25 is 5. So A therefore is 5. Do not tell me that the value of A is 25 because that is A squared. From the formula, standard form, the equation of the ellipse, that is the A squared. Therefore, 16 is the B squared. And to find for the B, you get the square root of 16, the answer is 4. If ever that B squared is not a perfect square number, for example, B squared is 15. So your B is the square root of 15, or what could that be? Decimal, square root of 15. 3 point something like that, no? When you're going to graph. But maybe you can end up with the radical value square root of 15 for the value of B. Upon graphing, you find the value of the square root of 15. What about the vertices? So the question there is already answered for center. Let's now find the vertices. The graph is horizontal, and the center is at 3 and negative 2. So therefore, when you plot the first vertex, from the center going to the right, 5 units going to the right. So we add 5 units to 3. Get it? And from the center going to the left, 5 units. So we subtract 3 by 5 as well. Therefore, to find for the vertex class, we can have the solution vertex could be 3 plus and minus 5 and negative 2. Again, 5 because A is the length of your vertex to the center. And since the graph is horizontal, so what moves upon graphing the vertices will be the coordinate for x. So we have plus and minus 5. Add 5 going to the right, subtract 5 going to the left. For the foci, since this is also located in the x-axis, then we will have to consider the value 3 plus and minus c and negative 2. We still have to find the c class because that b will be the intercepts. Okay? The b is your intercepts. You get what I mean? Question before we proceed? So to find for C, later on, we'll do that one. If we are going to use the value of your B, just a thought, we can find the intercepts. The intercepts, B and B prime, can be computed by 3 and negative 2 plus minus 4. Why is it that we added and subtracted it with the coordinates of your y class? Because from the illustration, your B is the change of coordinates of your y, going up and going down. So, kini na po si y-axis ato ang subtrakan o adan o 4, positive and negative. Okay? So, with that illustration, we can now calculate the length or the coordinates of your, the coordinates of your vertices, and that would be negative 2 and 2, 8 and negative 2. Okay? So this one class here, wait. Nagsagol na siya. Let me erase the line. This one here class is your only coordinates of the vertices. Okay? This is the vertex prime being on the left, and this is the vertex being on the right. These values are your intercepts, B and B prime. Okay? Wrong is here. Vertex is only that one. So this is your intercepts. Intercepts. Yeah. Okay? So from the equation or from the center, the coordinates of the center, going to the right is your vertex, going to the left is your vertex prime, going up is your intercept, going down is your intercept prime, which is noted by the following coordinates. Get it? Now let's find the coordinates of your foci. By the way, class, if I'm going to ask this question, you may not include the intercepts if it is not needed. But if it is stated, then include the intercepts. Then let's find the value of the C. From the formula, class, A squared equals B squared plus C squared. Diba? This one is what we have a while ago, but I wish you to transpose B squared a while ago. So we ended up with the formula A squared equals B squared plus C squared. So what about we'll use the original formula? A squared minus B squared equals C squared. Since we're looking for the value of the C, substituting A, which is 25, or rather 5, and B, which is 4, so you'll get 5 squared is 25, 4 squared is 16. Add the two values or subtract the two values, you'll get a 9. 9 minus C squared, or 9 equals C squared, get a squared on both sides. So C therefore is 3. So that 3 will be added to the coordinates of your center at X, since focus lies in the X-axis. So your center will now become, or your focus will now become 3 plus minus 3 and negative 2. Ergo, your equations will be 0, negative 2 for focus prime, and 6, negative 2 for the focus itself. So, yun sa niya class, sinana na siya ha. So, focus from 3 plus minus the C, which is 3, and negative 2. Simplify that, plus minus, you'll get 3 plus 3 is 6. 3 minus 3 is 0. Same goes with the intercept class. The intercepts would be 3 and negative 2 plus minus 4. So negative 2 plus 4 is positive 2. Negative 2 minus 4 is negative 6. And then for the vertices, you have 3 plus minus 5 and negative 2. Which are the coordinates here as simplified? Lastly, find the eccentricity. The simple value of the eccentricity is the ratio of your C divided by the A. C is 3, A is 5, so eccentricity is 3/5. Ay, nawa. Where's the eccentricity? It's not stated here now. So the eccentricity, by the way, here is 3/5 class. 3 over 5. Questions? Clarifications? Find another example? Wala po. Okay, this one class. This orientation now is different from the previous problem. The orientation here, class, is that 25 is the denominator of x, and 25 is way bigger than 16, so therefore this is a horizontal graph. In the next example, the value is 169 and 144. Comparing the two values, obviously 169 is bigger than 144. Therefore, this is your A. And if this is your A as a denominator of y, then your graph is a vertical ellipse. Okay? So this is a vertical orientation. In other words, you have now the center here, x minus h, so that is positive 5, y minus k, so that would be positive 2. Center is that plus and minus 2. 169 is the value of your a squared, and 144 is the value of your b squared. Therefore, the square root of 169 is 13, so that's the value of your a. And the square root of 144 is 12, that is the value of your b. Giving us now these values. Again, this is the intercept. This is the only coordinates of your vertices. This is intercept. So, 5 plus 13 is, rather not 5, 2, because this is where your vertex is located. Here, this is your vertex here, and this is your vertex prime. This is your intercept, and this is your intercept prime. So therefore, from the center to 13 units going up is the value of your vertex. So this is 2 plus 13 is 15. And then 13 units going down as the values of vertex prime. So 2 minus 13 is negative 11. Similarly, plotting the intercepts going to the right, you have 5 plus 12 is 17, and 5 minus 12 is negative 7. So that's the intercepts. For the foci, we have to find the value first of the c with the formula c squared equals a squared plus b squared. So therefore, c is equal to 5. 169 minus 144 is 25. Square root of 25 is 5. So c is equal to 5. So your foci now is going up and going down. So positive 2 plus 5 is 7. And positive 2 plus 5 minus 5 is negative 3. So your foci is at 5 and 7 and 5 negative 3. Your eccentricity is 5 over 13. Clarification?
Wala po.
Let's proceed. Let's proceed.
Sir, yun sa pag-find ganit sa NGCT, sir? 5
Eccentricity?
over 13? Yes, sir.
Formula na sila. Eccentricity is equal to C over A, man. That's the formula. And then we have the value of your C and your A. So, yung mo lang i-substitute.
Okay, sir.
13 over 5. Mara na siya. The use of eccentricity will be, and then I think there's a problem in your module that has a given of eccentricity. I'm not just so sure. There's that in the module. Now, let's continue class. So this is the summary of the formulas for vertical ellipse and horizontal ellipse. Still the same. This is what I just mentioned a while ago with how we find the major axis and the minor axis or the vertices. So we have here plus minus whatever the value of your A. For the minor vertices or the intercepts, the K will be added by the value of your B. And then for the focus, the value of the H will be added by the plus and the minus of your C. No. I think this is not in the module, so you can take a picture of this one. Let's have examples, more examples. By the way, class, before we end this slide, there's an additional information here that is not presented in the slide class. Since we have a focus and we have values of your A, B, and C, an additional line that you need to create is a line perpendicular to the foci. A line perpendicular to the foci. And these lines are what we call as, do you think so? These are your latus rectum, okay? But since there are two of them, so the term is latera recta. In some references, this is termed latus recti, okay? But in one of the references I have in my calculus book here in by Peterson, the term given, the term used is latera recta for the two latus rectum. What's the formula for latera recta, class? The formula for latus rectum, LR is equal to 4b squared. That's just a squared. Squared. Yeah. 4b squared over a. Okay. This is the formula for your latus rectum. I'll double check it here. The values of the latus rectum will guide your graph. The values of these latus rectum will eventually lead us to the computation of the exact graph. Or not 4 pala class, 2b squared. 2b squared over a. The value of your latus rectum is 2b squared over a. In the parabola, that is 4a or 4p. But in an ellipse and in a hyperbola, the formula for latus rectum is 2b squared over a. Can I use the items in your module for my example? Or at least we'll get to understand it.
Yes po.
I'll share screen the module na lang. Share screen. Here. Sira natin eh. I am not going to answer 1 and 2 kasi yun naman na. So let's answer those which are not easy. Let's have number 2, class, of this problem. No, para at least in the Thursday, gamay ra tag solvo, no? So in number 2, class, we have here, find the coordinates of the center, the foci, and the lengths of the major and the minor axis for the ellipse with the given equation. So if you are going to find the values of your A, B, and C, we need that the given is like this, diba? We have to make sure that the given is somehow the same with this one. Wherein we can directly find the value of your A squared and the B squared depending on the given units or values here. But what about if the given is like this? This is the general form of the equation pala, class. Equals 0. What equals 0? What if the given is like this, class? Wherein you have the expression expressed in general form. No problem with number 4 because this is very easy for us to do. So we'll do this one class para at least you'll know for sure what to do next in the upcoming summative test. We have to complete the square in order for us to arrive at the standard form of the equation of the ellipse. So from there, we get to have atong group together x squared and then minus 8x plus group together as well the y squared. So we have 25 y squared minus rather plus 100 and then transpose on the other side of the equation the constant, so that will become negative 91. After that, before completing the square, you need to make sure that the quadratic term contains a linear coefficient. So from this example, we have to factor out 25. So upon factoring 25, 100 will become 4. Tama? So 25 y squared divided by 25 is y squared. 100 divided by 25 is 4. About here, we need not to do so because it is already being, or it is already having the coefficient of 1, the quadratic term. Get it? Now, let's proceed with the completing of square. So from this expression, to complete the square, wait for a while. We have here 8x. The coefficient of your linear term, negative 8x is negative 8 divided by 2, which is negative 4. Square negative 4 is 16. So this is plus 16. So on the other side as well, this will become positive 16. Tama? And then this will be our, ano, wait, it lacks the y. It should be y. So let's complete the square on the variables y. So this will be 4 divided by 2 is 2. 2 squared is 4. So this is plus 4. And on the other side, this will become plus 4 times 25. What is happening, sir? Anong plus 4 man na siya? Nakanay 16 ra. It is because, class, the completing a square here is in the inside of the parentheses where 25 affects all the values in the inside. Naturally, this is supposed to be 16 times 1. Right? Or to put it this way, this value here is supposed to be plus 4 minus 4. Then transpose the negative 4 to the other side. May mo na siyang plus 4. But we will not do so at this moment so that it will not confuse us. So the idea of the equality here, class, is whatever you add to the left side, you are also going to add it on the right side. But since you added 4 here within the parentheses of 25, so you're also going to add here a 4 within the parentheses of a 25. Clarification? Okay, so since there are no questions, so let's proceed. So we have now the expression as x squared minus 8x plus 16, a perfect trinomial square. So we can raise it to, we can factor it out as x minus 4 squared plus 25, and then factor out the perfect trinomial square as well. So we have y plus 2 squared equals negative 91 plus 16 minus 25, plus 4 times 25. Allow me to use a calculator, class. So we have 100 minus 91 plus 16. The answer is 25. Now, class, our target is this expression, the one with the denominators of both terms in your expression to the left. But on the right, it should only contain a 1. Therefore, let us make this 1 as well. And how we are going to make that a 1? How to make this 1, class? We are going to multiply or divide all of the terms in our expression here by 25. Here by 25, and here we have to divide this by 25. So in other words, this simplifying class happens because we want to achieve that the left side, or rather the right side, will be equal to 1, as 25 divided by 25 is equal to 1. And now, simplify it further. What about 25 divided by 25? This will also be equal to 1. And 1 divided by 25 stays at 1 over 25. So therefore, we have now this expression as our standard form of the equation of the ellipse in number 2. So therefore, the vertex here now goes with, the vertex here now is equal to 4 and negative 2. Where do you think so that the graph is located? Is it a horizontal ellipse or a vertical ellipse? From the illustration here, class, 25 is bigger than 1. Therefore, this is your A. And your A is the denominator of X. Therefore, it is a horizontal ellipse. Horizontal ellipse means that the A is located in the x-axis. And from that illustration, we have 25 equals A squared. So A, therefore, is equal to the square root of 25, which is equal to 5. Similarly, B squared is equal to 1 as the value indicated in the second term. So square root of B squared is B, square root of 1 is 1, therefore B is equal to 1. Ito i-find the rest of the C class. From the formula, C squared is equal to A squared minus B squared. Ako rin baylo daan but in the formula in the session that we had just a while ago, it's A squared minus B squared equals C squared. So the values there goes with B squared or 5 squared minus 1 squared. And then what is 5 squared? That's 25. 1 squared is 1. So therefore, C squared is equal to 24. C, therefore, is equal to the square root of 24. Okay? So from these values, class A, B, and C, we can now determine the coordinates of your vertices. Oh, by the way, this is not vertex to the class. I'm sorry. This is the center. Okay? So the value of your vertices can be computed from the center. So the vertex now goes with 4 plus and minus. A is 5 and negative 2. Or you can simplify it as vertex equals 9 and negative 2 followed by the second vertex, the vertex prime at 4 minus 5. That's negative 1 and negative 2, right? So that is the simplified form of the expression we just had here. You can also answer this one, class. 4 plus minus negative 2. Or you can expand it like this. Either way, it's up to you guys how you're going to solve your answer then. Let's proceed with the focus. Focus is equal to, since that is the C, right? And then your focus is also the same with the x-axis. So therefore, focus is 4 plus and minus the square root of 24 and negative 2. Okay? Para we will not anymore involve decimals, we just have the values 4 squared, 20 squared of 24. If you wish to expand the values then in individual coordinates, you can have focus equals 4 plus, let me copy this one, Control C. So 4 plus the square root of 24 and negative 2. Sorry. And negative 2. And then the other value would be focus prime is equal to 4 minus square root of 24 and negative 2. So probably that will be the end result of your coordinates to the focus. Or if you have it in the decimal, square root of 24 would be 4.89. 4.9. Lastly, intercepts. Let's proceed to the intercepts. B. B therefore is equal to 4. And then since B is going up and going down, let's have the -2 then. -2 plus and minus 1. So if you're going to express the B in individual coordinates, that would be 4 and -2 plus 1 is -1. And then the other coordinates for B, which is B prime, will be at 4 and -2 minus 1 is -3. So this is now the coordinates of your intercepts. And lastly, let's try to express the eccentricity. Kasi mga loads eccentricity, no? C over A. C over A. So the eccentricity therefore is square root of 24 over 5. Yun. What else is lacking here? Okay, so these are your answers, class. Or perhaps you can just end up with the answers. Hindi ra gud oh. Pwede ra gud kinin yung answer, class. Kani kana kana ay wait. You can have your answers as this one. I will consider that. This one and this one. Pwede ana ra taman. Ana rang tulo. The associations of the plus and the minus. Clarifications, questions? Uy. It's already 11:50. If you have questions and clarifications, class, just chat your concern in the GC. Type your concerns. I wish that I can solve this face to face so that everyone can be clarified, but I doubt if I can do that at this point in time. So if you do have a question, then feel free to raise it.
Sir,
Yes.
di ba V is the vertex,
Mm-hmm.
then the F is foci, and the B, sir? What is the B, sir?
Intercepts.
Okay.
The length of the minor axis.
Mas
B
taas,
stands for the minor axis. Yes, Miggy?
ay, sir.
Oh, Troy. Yes,
Mas
Troy.
taas ang C kaysa sa B.
Dili, necessarily. For as long as A is the longest of the three, whether B is longer than C or C is longer than B, it doesn't matter at all. Dili necessary na nga dapat si B dako ni A. Dapat si B taas ni C. But consider this condition, class, that C is always the longest. A is always the longest of the three values, A, B, and C. So A yun na siya ang pinakataas. Any other concern? Well, if you have more concerns, class, feel free to chat your concerns in the GC or you can chat me in the messenger personally. That would be all for today. We can take our lunch now.
Goodbye.